Good afternoon, good evening, everyone. Maybe now is the time for the starting. Not yet? どうなんだろう。So, yeah, okay. Yes, we can wait some more. Hello, Manan-san.
Hello, son. How are you?
Yeah, fine. How are you?
Yes, fine.
Changing now. In Japan, it's very not midnight, but evening time.
Yeah. So you are feeling sleepy?
Not yet, but sound hungry.
Okay, so welcome back everyone again to this session at International Conference on Climate Change. So this time it's technical session 2A. The title is Impacts of and Challenges of Climate Change. So we will be having again two distinguished professors taking over the sessions. So Professor Dr. Toru Terao from Kaga University, Japan, will be the honorable chair, and it will be the honorable session co-chair is Professor Dr. M. Shahjahan Mondal from Institute of Water and Flood Management, Bangladesh University of Engineering Technology, BUET, Dhaka, Bangladesh. We will have again some lively, some very informative presentations, and the first one is basically the session talk for this session, and it will be done by a very respected and distinguished meteorologist from Bangladesh Meteorological Department, Dr. Mohammad Abdul Manan sir. So I'm not going to take any longer. I'm just handing over the session to the honorable session chair and co-chair. Over to you, both of the sir.
Okay, thank you very much. So now we can begin this technical session 2. The title is the impacts and challenges of climate change. So we have 2A, maybe two parts, 2A and 2B is there. So I like to chair the former part, the technical session 2A with Shahjahan Mondal-san from BUET. How are you, Mondal-san?
Good afternoon. I'm fine, thank you. How are you?
Yeah, very nice to co-chair with you.
Nice to see you after some time.
Yes, yeah. So now we are developing with Professor Shahjahan Mondal in BUET about some very quick investigation of how we develop our research collaboration about the flash flood in the northeastern part of Bangladesh and regarding the climate change. So very happy to co-chair with you. And I think this session very important because climate change is so much important topic in Bangladesh because Bangladesh is so much vulnerable to the climate change, as you know. So these sessions may have the very fruitful and also the very informative for the future measure how to take and how to mitigate our effect from the climate change. So anyway, we can begin from some word from Mondar-san also. Please give some word from us first.
No, thank you. I mean, you can start this session. So,
yeah,
and let's see how it goes.
Okay, we can begin naturally then. So the first speaker is already introduced by the supporting staff. The Dr. Mohammed Abdul Mannan-san, our friend, and he is from BMD, Bangladesh Meteorology Department, and his title is Heat Wave in Bangladesh and its Future Projection. So, could you please start the presentation?
Yes, thank you, Terav-san, and Honorable Chair and Co-Chair and the audience. Can you please confirm me whether my slides are visible or not?
Yeah, it is okay, but maybe it is not the full screen mode, so you can make it.
Okay.
Yeah.
Okay. Okay, now it's okay?
Yes, perfect. Yeah, please
Okay.
begin.
Okay, thank you very much. So welcome everybody to my presentation. Actually, my presentation title is Heat Wave in Bangladesh and its Future Projection. You might be knowing that Bangladesh is a heat wave prone area, that means high temperature zone, but it has been very much influential over the pre-monsoon season, especially March to May, as well as some part of June. But what happened in the recent time, what we found that the heat wave period has been extended even up to October, September also. And again, it has the coverage area not only concentrated over the western part of Bangladesh, even though it has been extended to be found over the southeast and northeastern parts of Bangladesh. That's why our concern is there. What would be the future scenario of this one? And how it is being behavior? What are the reasons behind of this heat wave condition? How it has been becoming prolonged during the recent times over Bangladesh, and how it has given the influence to the society. So to understand this situation, actually, I have taken this initiative to understand what will be the future scenario of this heat wave condition in Bangladesh. And we all know that it has the good influence on the society. It becomes disrupting all of the activities of the society. Even we have seen some pictures, even road people are also suffering a lot. And the city people has also suffered a lot. And we found that in the global arena, so many organizations, different countries are being suffering the last year's heat wave condition, even though it has been aggravated at many parts of Bangladesh this year, as well as many parts of India, Pakistan, as well as even Europe also. So to understand this situation, actually the responsibility always go to the national meteorological services, but even though it has some responsibility has go to the even researchers also. So we can analyze this, and accordingly I am trying to present in front of you. As of our understanding, what we found that there is no universal definition of heat wave. That means when temperature goes up, when it is becoming beyond the tolerance, it has been treated as a heat wave condition. That's why it has the definition at different parts of the world in different way, because different parts of the people of the globe of the people are having different heavy situation. So accordingly, they have been prepared the definition, or they have been determined the definition in different way. Even in our neighboring countries, what we found that the India Meteorological Department, they have the definition that is very different from Bangladesh also, because the tolerance as well as the impact on the society, as well as the longevity and other phenomenal behavior is different than in Bangladesh. You might be knowing that Bangladesh is a green area, but even though when the temperature goes up and some associated features are lying with that, our people are also suffering a lot. So based on the societal impact as well as some other information, Bangladesh Meteorological Department has been clarified the heat wave definition in such a way in different category. That is, the lowest one is the mild heat wave. That means when temperature lying 36 to 38 degrees Celsius, and moderate heat wave has been declared when 38 to 40 degrees, and severe heat wave has been considered in 40 to 42 degrees Celsius, and very severe heat wave is greater than 42 degrees Celsius. Of course, some mathematical information is lying with that. It has to be built up beyond the normal behavior of the temperature over Bangladesh region. That's why some deviation of temperature, that is 2 degree, 4 degree, 5 degree, and 6 degree, and beyond that it has also been considered, and accordingly its duration, minimum 3 days duration, are also being considered with the definition of Bangladesh Meteorological Department. And that definition I have taken into consideration. 2021 and 2022 heat wave has been occurred over Bangladesh region, and how it has been given its influence on the society. And to do this, actually, I have been collected the daily temperature records of Bangladesh Meteorological Department, and according by definition of BMD, I have been considered the information to calculate other processes, and accordingly to understand over Bangladesh and its surrounding area, because surrounding area is becoming susceptible for heat wave beyond Bangladesh region, and it has the influence first over the outside border region, and then it has been intervening over Bangladesh. So we need to know what are the, how it has been initiated over the Indian territory, that is West Bengal, Bihar, and adjoining area, and how it has been propagated to Bangladesh region, and how it has been covered over Bangladesh territory, and some specific area also. To do this, actually, NSEP global data, daily maximum temperature data also I have been taken in the future scenario access CM2 model under CMIP 5 and CMIP 6 scenario has been selected, because this model, as of my understanding and as of the publication in the recent time, what we found that access CM2 is the one of the most suitable model for Bangladesh region to generate the high temperature quality, as well as it has the provision for addressing the monsoon related issues, and as well as the land and sea interactions, as well as ocean heat content also. To do this, actually, I have also taken the data from NASA Earth Exchange Global Daily Downscale Projection, that is NACS GDP CMIP 6.5 data, which I have been consolidated in the analysis. CMIP 5 scenario will be taken care of later on, and the data have the provision for 25 kilometer grid resolution, and bias correction has been taken, is the prominent bias correction, that is linear scale bias correction method has been taken, and then the result has been formulated. But of course, to do this analysis, I have to be dependent on the different program like R, Python, as well as MS Excel and other relevant softwares also. So let us have a look on the heat wave condition in 2021. Here it is. Here we have seen that on the top right figure, the heat wave has already been initiated in the last week of May, or I would say the last part of May. Then it has been continuing even first week of June. During that period, there are 4 prolonged high temporal and high spatial resolution events has occurred over Bangladesh region, that is 21 to 27 March and so on. And similarly, it has the cover over beyond the earlier climatology, that is over southern and southeastern parts of Bangladesh, including the central part of Bangladesh. Then let us have a look at the second one in 2022. You might have seen that from March onward, it has started and it has been continued up to first half of September. As you have seen that most number of meteorological stations have recorded during that space high temperature as above than 36 degrees Celsius, and accordingly it has been continuing in some cases 5 to 7 days, in some cases even 10 days or more also. And interestingly, in August, it has the good coverage area over Bangladesh territory. That means during the August, heat wave condition, it has covered over southeastern as well as northeastern part of Bangladesh. That is what I already mentioned. That means its temporal coverage is very, very high than the 2001, and its spatial resolution is also becoming very high than the earlier periods what we have been recorded in from Bangladesh Meteorological Department. Let us see how it has been happening over Bangladesh region. On the top right panel, you might have seen that there is an anticyclonic flow. This anticyclonic flow is the responsible for providing moisture content over Bangladesh region, and on northwestern parts of Bangladesh, you might have seen that there is a convergence zone. And top left panel, you have seen that there is a low pressure trough which has been extended over southeastern parts of Bangladesh, and due to these, both of these systems, that means pressure system and a wind field, there is the high relative humidity persisting over Bangladesh region as a narrow band, and it has been given the lots of opportunity to lift the atmosphere, low level air particle to go up, and that means there is the provision for thermal low pressure for continuation for long periodic days. And again, it has been given the unstable weather phenomena. That means the heat wave was prolonging due to these two weather phenomena. That is my submission over here. Now let us see how it has been behaving over this particular period. In 2021, we are trying to having an interest to how it has been impacted. Really, it has the impact over southwestern part and western part, or it has the impact at other places over there. To know that one, heat index has been calculated, and what we found that it has been enormously impacting over the coastal southern part of Bangladesh in addition to central part of Bangladesh. That is the new beauty of the heat wave features in the recent time what we found. Even in 2022 cases also, we have found the similar phenomena. That means though temperature doesn't go very high over the southern part of Bangladesh, but even though it has the influence over the coastal area, and no, not only that, even some people who are engaging in fishing over the Bay of Bengal, that means the northern part of the Bay of Bengal, they are also expressing this high temperature condition is unbearable to them. That means it has the influence over the even northern part of the Bay of Bengal also. Now let us have the interest how the model is behaving. To know that one, actually I have been trying to generate the event for 2014. I found that yes, model is able to Are you looking? Yes, 2014, the model has able to capture the heat wave phenomena which we have been observed from the as per the record, as per the global data, as per the BMD records. In the right panel in 2005 and 2014, that is the number of occurrences of maximum temperature beyond 36 degrees Celsius. That is what we found, that western part as well as some part of southern part have the influence of this event, especially in 2014 also. That means what we found, that model history is able to capture the heat wave phenomena over Bangladesh region. With this, again, I have been trying to find out let's see how in future model is able to project this heat wave phenomena over Bangladesh region or not. That is what you might have seen, that one event in May 2030. We found that the heat wave situation originated over the West Bengal and adjoining area. Then it has been extended over the central as well as the southeastern parts of Bangladesh, which we have already been started to observe over Bangladesh region. So with this attention, actually, I have been trying to select two objectives. One is to understand the vulnerability of heat wave, and second one is to generate the projection of heat wave scenario for Bangladesh region. So for this, actually, I have been taken 4 scenario of CMIP 6 models. Scenario SSP 1 to 6, and through this scenario I have been trying to generate 2036 scenario 2050 as an individual window 2070 and 2001. Even some parts of eastern region of Bangladesh also, in the western parts of Bangladesh, but it has the extension over Bangladesh. Other parts of Bangladesh. In 2070, though it looks quite weak, but it has the extension over central part of Bangladesh, even some parts, or I would say maximum parts of the southeastern part of Bangladesh. In the recent time, I want to mention over here again, in the recent time in the Rangamati, facing this heat wave situation very frequently, what we have been observing. And in the case of 2100, you might have seen that the number of events even recorded in some parts of Bangladesh, even 120 days. That means within 120 days will be the provision for Bangladesh region to record the heat wave situation in Bangladesh. And similarly, in the case of SSP 245, we have 2001 as well as 2070. This situation is very, very worse. What we have been right now observing than that.
Maybe you have 2 minutes more.
In 2070 as well as 2100. Okay, I will finish. And 70, it has the coverage, and it has in 2100, it has covered most part of Bangladesh. No more parts is remaining under its threat. That means the heat wave condition. And similarly, in the case of SSP 585, we have found that it has covered over in 2100 most part of Bangladesh, like earlier scenario. To formulate this one, to see what are the situation lying at the locality. Let us see, have a look at the place of Rajshahi, Dhaka, and Khulna divisions, divisional station places, and these three are the most vulnerable region in terms of heat wave. And in the central part, Dhaka is most likely we are facing this sort of problem. And we found that this is the annual behavior of the heat wave days over these 4 scenario. Again, if we see this one, and if we say the decadal behavior of the heat wave condition, what we found that from 2030 onward, the heat wave situation is consecutively increasing for all the scenarios. And even if I have been in the right panel in the table, you might have seen that in some years, even more than 50 days, on an average, the heat wave situation is likely to be projected over Bangladesh region. Similarly, in the case of projection for Rajshahi region, what we found that it is being continuously increasing. That means the behavior is worsening over that period. And here we might have seen that in the case of Rajshahi, if we go from time from top to bottom in the right panel, that means 2021 to 2100, we found that the number of heat wave days are being increasing. Similarly, if we go from left to right, again we found that the number of days are being increased. That means situation is worsening. Similarly, Khulna, similar features is there, and if we found that in the case of Khulna, that is also situation like this, it is being increasing. And again in the right panel, we might have seen that in some places near to 2100, the number of heat wave days even more than 4 months also what we found. That means duration is around 160 to 200 days, 200 days also. So based on this analysis, actually, I want to conclude very shortly in that way. Bangladesh is susceptible for heat wave. Model projection depicts more risk related to the heat wave condition over Bangladesh. Coverage area of heat wave is also projected to increase as per the model what we have seen. Heat wave may become more crucial by 2030 and its afterwards. And this is the high time to provide more attention on heat wave and its sectoral implication. And then the early warning on heat wave may therefore be enhanced further to give the relief to the local people and to make them prepare well ahead of time. And then my final comment is study on the heat wave is also a prime requirement. That is my submission. Thank you, everybody. Thank you for giving me chance.
Thank you very much. And so it's very interesting. And so the heat wave also very big problem for the future in the Bangladesh region. And you can understand so much. But the time is already finished. So I'd like to go with the next speaker. Thank you very much for Manan-san. So if you have any comments and questions, please put them into that chat system. Then we can discuss later after the sixth presentation finish. So please put your questions to the chat. Please to whom that comment or question is done. So please. Thank you very much. So now we move on to the next speaker by Dr. Muhammad Kamruzzaman from Bangladesh Life Research Institute. And the title is Precipitation and Temperature Changes in Bangladesh based on CMIP6 GCMs. So please begin your presentation. Now just sharing that, yes, yeah, that the presentation now in the full screen mode, so it's very nice. Please begin. Perfect.
Can you hear me?
Yes. Okay. You can begin now.
Okay, thank you very much, Professor. Today, my presentation on the future change in the precipitation temperature over Bangladesh based on the CMIP6 GCM or global climate model. Before I go into the presentation, I would like to introduce myself. This is Kamruzzaman from Bangladesh Rice Research Institute. The presentation just show you the recent past extreme events in Bangladesh. You see the newspaper headline. Into 27 September 2020, you see there is the huge rainfall in the Rangpur region. Actually, in 12 hours, 433 millimeter rainfall occurred in Rangpur. This is the history of the last 60-year history. Sometimes the newspaper reported. Another extreme event in Bangladesh we found based on the 4th April 2021, there is a heat wave. The last presenter said the heat wave, that is especially the 4th April in 2021. That is the situation where was the extreme, the average rainfall in the April in the 33 degrees centigrade, but at that time it was then 36 degrees centigrade, and the lower relative humidity. Actually, the mechanism of the antithesis period of the rise, there is a heat shock, and all over the country there is a major portion of the rise was stayed in that occurrence. And this year, everybody knows that this year there is a huge flash flood in all the early April. This was the situation. So extreme event each and every year in Bangladesh, extreme we are facing the challenge due to the change of the climate change and based on the extreme event. That is why it is very important in our agriculture as well as another water sector or another sector to project the research in the climate related information in future. So we need in our country to make to save this situation. So more research is required based on the climate change scenario, and also make the planning in terms of the research or infrastructure and another things based on this information. In globally, you see the global context, the sixth assessment report, the last assessment report, they're providing the scenario and the CO2 concentration they're predicted, and the global surface temperature also predicted the 4 degree, above the 4 degree will be increased in the global. This is actually the global information, but we need to information the local scale as well as the regional scale. That is why I am planning this research to use this information, the study background and data methodology result. I am planning this research. Before As you saw, the long-term rainfall and temperature projection as the vital, the future management plus of the water resource agriculture in Bangladesh. Actually, you know, the all global climate model are available, but it's the global scale. So we need to the information about the local scale. That is the our main things, main thinking about. So because the global climate model are designed more than 100-kilometer resolution, it is not and some is not the suitable mimic our climate and our local scale climate. So we need the downscaling technique, the statistical or dynamical downscaling. In our study, we are using the statistical downscaling techniques. And also we have a lot of the global climate models. Each and every climate model, they provide the information. Actually, they have many information. They are not the same information. That is why we need, there is a lot of the uncertainty. So we need to use the uncertainty, minimize the uncertainty of the climate models related outputs. So we use the ensembling approach is the appropriate. That is why we are the main objective in our study. Actually, we use in our study 18 global climate model and 3 future period and 4 scenario at the annual and also the seasonal time scale, and also use the trend analysis of the climate. This is the data. Actually, we are using the era 5 climate data as a base data, reference data. We are not using the station data. Actually, we are found the high resolution data climate, so 25.25 degree resolution climate era 5 data set from and also the 18 GCM data. And we use the downscaling and bias correction simple quantile method. Simple quantile mapping method we use in our study, and we have we developed the software, our SQM package. We use this package, and the performance evaluation of the era 5 and the global climate model, Taylor diagram we use, and projected change analysis we just simply change use. If you found that the technique of the bias correction technique, this is a very important technique. We use this technique actually we are the object data set and also the model data set. Just we are correcting the bias this technique economically, and also with the trend analysis, modified man control test we are using here study. This is actually the evaluation of the bias corrected result. We found the upper row is the rainfall Tmax Pmean. Actually, this is scattered and the before bias correction, and after bias correction, it is concentration in the observation. So we can find the bias correction is okay. And also, if you found the monthly, it's almost the same. Found the same things, the monthly scale. And if you found the before bias correction, there is a huge bias. We found that underestimate the precipitation, most of the things, and also the overestimate the temperature at maximum temperature and the minimum temperature. But after bias correction, it's already bias is removed here. That is why we can say that our technique is okay for the future projections. This is the annual temperature projected change. We found that our main things that precipitation and the percent change of the precipitation base period was the 1985 and 2014. This is the base period. Based on this period, we have the change. We found that the highest 47.9, almost 18% precipitation will be increased in future due to the SSP 585 scenario, and also that is the things. And the temperature, we found that the highest temperature change in the end of the century, and it will be 2.9 and about the 3 degree, above the 3.5 degree. And also the minimum temperature also since near about 4 degree above at the end of the century. this is the spatial variability of projected precipitation sinks. If we see the result in the fourth scenario result and the near future, mid future, and far future, well, we found that the rainfall will increase in all scenario will be increased, but highest increase in the end of the century and northwest this part. This is the change actually. Don't confuse this. This is the change actually. This portion and this portion also the change is the highest. Northwest Bangladesh, the change will be highest. And that is that maximum temperature also we have projected the temperature. We found that in the near future the temperature will be all the increasing trend, not the decreasing. All temperature are increasing. Actually, we are using the mean temperature, not seasonal scale here. We are using mean temperature. All of the all are increasing, and the end of the century it will increase more. And if you find the minimum temperature of the same trend and southwestern coastal region, it will be increasing the more. And if you see the seasonal scale, the pre-monsoon season and the post-monsoon and the winter season, we found that the precipitation, the monsoon and post-monsoon precipitation will projected to increase highest in the 20 to 41% increase. And the winter precipitation also decreasing trend. This is our findings that winter precipitation will decrease in future, but pre-monsoon and monsoon, post-monsoon precipitation and increasing in future. And temperature, in terms of the temperature also, we found that the 3.4 degree centigrade temperature and the 4.26 degree is the minimum temperature will be increased in the future end of the century, and the 585 scenario in future, far future. And the trend analysis, we found that the trend analysis, the annual rainfall is projected raise the 93.59 millimeter per decade. This is the decadal scale. That is the scenario, fourth scenario. This will be increased. And also the Tmax and Tmin also projected. And we found that the 44 degree centigrade and 0.53 degrees centigrade per decade, it will be increased in the end of the century. And with this scenario, this is actually the rate of the changing rate. And the spatial pattern also the same. Also, we are showing that all of the significantly increasing. Actually, the result is most of the significant. Some of the scenario have some portion of the change is not the significant. This is a very minimum area, but all area the increasing scenario is the significantly increased. And the uncertainty analysis in our study, we are doing the uncertainty analysis. We found that highest uncertainty will be found here, the end of the far future, and for temperature and precipitation and minimum and maximum temperature. Also, the far future uncertainty is high. Actually, this is the we need to actually minimize the uncertainty of the climate change scenario, which will be impactful. It will be help in the assessing the impact of the climate change in Bangladesh and all over the country, all over the world also. Actually, this is the conclusion. What we found in our study, we found that the annual projected rainfall significantly increased in the most of the Bangladesh between 2055 to and the beyond, and that is the actually the significant increase. And the average rainfall is projected to increase the 21%, 19%, 30%, and 48%. The fourth scenario, respectively, in the 21st century. And the maximum temperature and minimum temperature are projected to rise by the end of the century. All scenario also, and Tmin also predicted to rise faster than the Tmax. We found the post-monsoon season will experience the greatest increase in the precipitation. Actually, in the October and November, precipitation will be increased in the future. great case, and a decrease in the precipitation, near of the 15% precipitation will be decreased in the winter in the mid future scenario. And winter display the greatest rise in the projected Tmax and Tmin also in winter. So we can say that winter will be shrinkage in future, whereas the monsoon display that least raise the temperature and the respectively. The precipitation and temperature projection in Bangladesh is in the large uncertainty. So although the multi-model ensemble method reduce the uncertainty, more effort should be in future should be used. Say for example, in the machine learning or another approach should be applied in our research further study to minimize the uncertainty of the climate change impact assessment. Actually, this is my findings, and these findings can be helped in our long-term agricultural and also another water resource related research and the impact assessment. Thank you very much, and thank you.
Thank you very much. So we have some time for some question or the comments. So you have any question to comment now? If you have, please talk from your side. Is it okay? Oh, okay. Now,
if you allow me, I can ask one question.
Please, yeah. Thank you.
Yeah, thank you. I mean, to reduce the uncertainty, the approach, as I understood, followed is to go for multimodal ensemble, using multimodal ensemble. My question is there I mean, other alternatives to use than this one? Because, you know, when we use multimodal, I know IPCC is promoting this, but also there are limitations of multimodal ensemble because you are doing some averaging and you do not know what is happening within different models. So what is your experience regarding this using multimodal ensemble?
Thank you very much, sir. You raised the question is very important in our research. Actually, first time we evaluate the model, if you the particular regions, if you analyze the climate scenario. So first time we are doing that things, the lot some selection of the model, the best fit model, best representative model for Bangladesh. I have published an article. We are using some best fitted model in Bangladesh representative in the Bangladesh climate. And then you can do some ensemble tackling. In our study, we are using actually the just average things is the one technique, but there is a lot of techniques available. Say, for example, the machine learning approach, we can use that to maximize our result, maximize our result. If you use them, Bayesian techniques can also be used for better result and better output. This is the technique actually globally, but I don't know another technique have the minimize uncertainty.
Yeah, thank you very much. Okay, wonderful. Okay.
Thank you for the answer. I was actually looking for whether there is alternative to multimodal ensemble. Because machine learning, when you talk about machine learning or other techniques, you are still using multimodal.
Yes, yes. Actually, we are still using the multimodal ensembling technique. But because this study, we found that some model are good result for the seasonal forecasting, some seasonal scale, some are the good model, some model are the best fit in the annual output, seasonal output. It's a different, very model to model, very the result. That is why we use the multimodal. But some group of the model, they can receive better representation. Some model are good fit for the precipitation. Some of the model are fit for the temperature. Some of the seasonal. That is why this technique, we use this kind of the technique, the multimodal ensembling, and just average some good output. Thank you, sir.
Yeah, thank you.
Yeah, thank you very much. So maybe we can see much more about how the climate models cannot represent the real situation. So then we may learn from that. So in future, we may collaborate this portion also. Yeah, thank you very much. And so now I understand that some from agricultural view also, the researchers in agriculture also using the top level data sets and trying
Yes.
to produce that how the future will be. So it's a very interesting, very good
Yes, sir. Yes, sir.
exercise. So we can collaborate much more. Thank you very much. Thank you very much, Kamaru-san. Thank you.
Thank you, sir. Thank you.
And now we can move on to the next speaker. So Dr. Monjira Rizwan-san from the Bangladesh Air Force. And the title is Effect of Climate Change on Rainfall Trend of Bangladesh. Please begin your presentation. Can you share?
You need to unmute yourself.
Thank you.
Oh,
Yes. Thank you, sir. Respected session chair and respected session co-chair and learned audience. Assalamu alaikum and good evening. I'm Commander Montila from Bangladesh Air Force. Today, I'm going to present effect of climate change in annual rainfall trend of Bangladesh. So let me share my.
yeah, please. Yeah.
Yeah. Thank you. Okay.
Yes. Now, please make it into the full screen mode.
Yes.
Okay. Yeah, perfect. Yes,
So,
please. Yeah.
I must thank the convener of the of this conference and also the team of this conference for organizing this conference and selecting my paper. So my paper, Effect of Climate Change in Annual Rainfall Trend of Bangladesh. We all know that the climate change is quite apparent and global climate is changing. So, and this year also we have observed some extreme weather events which the scientists are referring as effect of climate change. That's why I select this paper. Actually, this is kind of data analysis learning for me. I have selected data of Bangladesh Meteorological Department. I must thank the authority of Bangladesh Meteorological Department, that is BMD, for giving me the data. And mainly from this data, I analyzed whether to identify the climate change over Bangladesh, in which region climate change is happening. So this research paper for this research or study, I have chosen man-candle trend test and sense slope estimator to identify the trend, and also I have done some calculated the climate normal with Excel. So the aim of my paper is to identify the effect of climate change in annual rainfall trend in Bangladesh. Or the sequence: first, I will define my research area, then data. I will talk about the data, research method, climate normals, man-candle trend test, sense slope estimator, result. Then I will conclude my paper. So for research, actually, I have taken 22 rain gauge stations of Bangladesh. Out of 35 rain gauge stations of Bangladesh Meteorological Department, I have taken the data of 22 stations. And we know that Bangladesh is actually, the climate of Bangladesh is temporal climate or temporal monsoon climate. In the western part of Bangladesh, that is in the Rajshahi, the annual rainfall is about 1500 millimeter. And other than this Rajshahi and western part of Bangladesh, most part of country receive at least 1800 millimeter of annual rainfall. And because of location, that is in the south of the foothills of Himalaya, the northeastern part of Bangladesh get maximum annual rainfall, and sometimes the annual rainfall cross 4000 millimeter. So this slide shows the stations I have taken with latitude, longitude, and year of data, that is how many years I have taken, and range of the years, that is 1960 to 2021. So I have in the given which data I have excluded because of the quality of the data. So there are some presence of missing data, and not some data is really confusing. That was I have excluded some years. We know that for finding the trend, we need a large time series of data. So monthly rainfall data series of maximum 62 years, that is 1962 to 2021 of Bangladesh Meteorological Department is used for this study or research, and missing data is observed in most of some of the stations in most of the year. That's why the years are excluded. So we know that World Meteorological of the organization, they as per the guideline of WMO, 30 years average is considered as climate normal. So in most stations, as around 60 years data is available, I have calculated climate normal of first 30 years and second 30 years. The stations who have data of less than 40 years or around 30 years, I have calculated just one climate normal. Then MK trend test is compared with the climate normals, and also sense slope estimator is used to get the quantitative data or to get the quantitative trend. So this table I'm showing that the climate normal. So this table shows the that in out of 22 in 11 stations, second climate normal is greater than the first climate normal, and the brighter color, that is Chattogram, Teknaf, and Khepupara, the climate normal, that is second climate normal, the annual rainfall is more than 100 millimeter increased than the earlier first climate normal, which is significant because it indicates that in the southern, that is over Chattogram, Teknaf, and Khepupara, rainfall annually is increasing more than 200 millimeter per hour. And this climate normal showing that in 10 stations actually rainfall, that is first climate normal, is less greater than the second climate normal. That is, rainfall is actually declining with time. I missed here in Srimongol, both climate normals actually become very close, 2345 and 2347. That is very close. For Borishal also, for first climate normal from 1961 to 1990, average is 2069, and for 1991 to 2020, average is 2057. That is very close, less than 10 millimeter. So why I have chosen Mann-Kendall trend test? Because it is a non-parametric trend and it doesn't depend on distribution. So null for MK trend test, the null hypothesis is that there is no trend, and alternate hypothesis is that there is trend. So p-value of Mann-Kendall trend test, if p-value is for this study, p-value is 0.05 in 5% significance level. So when value of alpha is 0.05 at 5% significance level. So when the value of p is less than or equal to alpha, that is null hypothesis can be rejected, and if it is more than alpha, there's more than 0.05, then it the null hypothesis cannot be rejected. So this slide shows the some result of MK trend test for Khepupara. The summary is that for Khepupara, rainfall is increasing at a rate of 12.886 millimeter per year. P-value is 0.004, which is less than 0.05. So trend is significant, and candle tau value become 0.286. That is association of with year and annual rainfall is moderate. For Chattogram also, I have got significant trend change, that is increasing of rainfall with year, 12.667 per year, and p-value is also less than 0.005 at 5% significant level. So, and association also, it is moderate association. For Rajshahi also significant trend we have found, but trend is declining with time. That is, over Rajshahi, rainfall is decreasing at the rate 5.513 millimeter per hour per year, and p-value less than alpha. But in other station, in this study, we have got that the trend, we have not getting any significant trend, and but sense slope, which estimate the rate of increase or decrease quantitatively, it for Dhaka, it is showing that over Dhaka, rainfall is declining at a rate 2.661 per year. For Sylhet also, rainfall increasing at a rate 3.5 millimeter per year. Faridpur rainfall rate is declining. For Jashore, rainfall is increasing. So this slide shows result of Man-Kendall and sense slope estimator. If I consolidated the data, so out of 22 stations in 12 stations in Man-Kendall test, showing rainfall is declining. That is, the sense slope is quantitatively showing the value. For Rajshahi, it is 5.5. For Srimangal, it is very less, that is 0.06. That is, trend is almost very slow, or we can say that no trend actually. For out of 22, for in 10 stations, actually rainfall is increasing or increasing with time. And for Chittagong, Khepupara, I have said earlier that it is more than 12 millimeter. Other stations sense slope value is showing here. So if I depict or show the test result in map, in the western and central part of Bangladesh, actually rainfall trend is declining with time. And another interesting thing is that over Borishal, Potuakhali, Bhola, here also rainfall trend is declining. But in the southwestern part, southeastern part, and northern part of Bangladesh, rainfall is increasing with time. So from this study, I can conclude that the rainfall trend show a large variability, special variability. In the Man-Kendall trend test, among the 22 stations, in 12 stations, downward trend, and in 10 stations, upward trend is observed. In 3 stations, MK trend shows significant trend at 5% significant level, that is for Chattogram, Khepupara, and Rajshahi stations. For Rajshahi, it is negative trend. For Chattogram and Khepupara, it is positive trend. That is, rainfall is increasing. So, inference is that annual rainfall trend is changing in Bangladesh with a special variability. Rainfall trend is increasing over northern part of Bangladesh, and trend is decreasing over central and western part of Bangladesh, except Borishal, Potuakhali, and Bhola. Over southern part of Bangladesh, rainfall actually increasing significantly. So some recommendations from this study is that the different trend in annual rainfall pattern are influenced by changes in atmospheric circulation due to climate change. we know that in some research paper, I got the information that due to climate change, as where sea surface temperature is rising, and as over Bay of Bengal, sea surface temperature is rising. In the coastal area, frequency of precipitation or rainfall amount is increasing over coastal area. So due to atmospheric change in atmospheric circulation, due to climate change, rainfall pattern is changing. Monthly rainfall analysis may give more insight of variation of rain pattern, whether temporal variation is also associated. Besides rainfall amount, research on monthly and annually rainy days variation may give prominent indication over that whether climate change influence on rainfall and seasonal shifting in Bangladesh. More rain gauge, that is meteorological station, may be established in northern and northeastern part of Bangladesh to get better rainfall pattern. I'm at the end of my presentation. So
yeah.
Thank you very much.
Thank you very much. So now you have any short questions, comments? Yeah, please talk. Okay. Okay, thank you very much. So now we have to move on to the next because some shortage of time. So thank you very much. So maybe we can have some time later on after the sixth presentation finish. So thank you very much for your presentation from BUF. It is also very nice, and you using the new method, and so I can compare with the results. So thank you very much. So Mondaro-san, I have a suggestion for you. Can you share from the next speaker? Maybe it's better.
Definitely. Thank you. Thank
I
you.
will control time, so you are please speak here.
Yeah. If you like, you can continue. I will be with you. No problem with me.
Please, yeah, it's better. Yeah, both of us can do something. So please.
Okay. Then I will continue.
Yeah, please.
So our next speaker is Dr. Dash. His topic is future floods in Bangladesh under different global warming scenarios. So Dr. Mohan Kumar Dash, I know him very well, and he has been working in this area quite a long time. So Dr. Dash, you can start your presentation.
Honorable Chair, Co-Chair, and distinguished audience, welcome to my presentations. So many of you know that Bangladesh is located at the delta of the GBM. This is well known as the Ganges, Brahmaputra, and Meghna river system, which is the second largest delta in the world. And the drainage area of this enormous river system just okay. Yes, the drainage of this largest river system of about 1.6 million kilometers square generates an average annual discharge of 1,350 cubic meter, which flows through Bangladesh before finally draining into the Bay of Bengal. So we can see the GBM basin in the figure. So there is a 3 outlets which is within the Bangladesh boundary. And very unfortunately, there are very limited or very few studies which we can found in the literature that assess the future changes in the possibilities of flood peak and synchronization of nearby large rivers, not only in Bangladesh, but in any regions. So the study is very much important because climate change is projected to increase the risks of water-related disaster, such as flood. It is mainly in many regions around the globe, and especially in Bangladesh and neighborhood regions also. So in this study, the main objectives is undertake. Just a minute. The main objectives of these studies to assessing the changes of floods in Bangladesh, which is caused by the global warming, special warming scenario, 1.5 degrees Celsius, 2 degrees Celsius, and 4 degrees Celsius. And to assess these kinds of scenarios, we have used a very well-known model that is called Soil and Water Assessment Tool, SWOT. Also, for assessing fluvial floods, this is the flood related to the rainfall. Daily precipitation data from the 13 different climate projections are analyzed. I will show in the data and method slides. The same data that are used to force the SWOT models. And finally, the changes in possibilities of peak synchronization are assessed, also using the SWOT simulated daily discharge. So in the study, I organized the study in data and methods, model setup, results, discussion, and finally some findings. There are several study, and if we go through the different literature review, we found that future changes of the flow of Ganges and the Brahmaputras will be increases. There are only a few available studies, as I mentioned, that show that the Ganges and Brahmaputra and Meghna rivers basin together. To understand the changes in flood condition in Bangladesh, projections of all three basins need to be made with consistent methodology with the same set of climate data. So the sea level rise due to global warming need to be considered and like to increase the severity flood as per the some study done by EQC and et al. 2015. So, but the thing is that the hydrodynamic model and related ocean related others requirement not in this study, but it need to be considered in some further studies. So in data, hydrological model is important as well as geospatial data is important, weather and hydrologic data and some others climate related data is also important. As I mentioned, SWOT, it is presently one of the most commonly used hydrological model for investigating climate change impacts on water resources at regional scales due to its flexibility of robustness. And SWOT is a continuous time model operating on a daily time step. So this is the beauty. You can consider the daily time step in this model. The study area divided into sub-basins in SWOT by overlaying a digital elevation model that is well known as the DEM and soil map and land use map. Different hydrologic response units, that is HRU, are then lumped into these sub-basins. Geospatial data and 90-meter resolution dam from hydrosheds, hydrological data map based with the elevation derived at multi-scale was collected used as topographic information of the GBM basins. And the study area I have shown that is the GBM basins, but the main focus is with our Bangladesh. So in GBM basin, it is shared between the India almost 64%, China 18%, Nepal 8%, Bangladesh 7%, Bhutan 3%. The elevation of this basin range from 0 to 8,000 meter above mean sea level. The Ganges basin has the largest area of the three. The Brahmaputra, it is about 9 lakhs, 7,000 kilometers square. And the Brahmaputra, it is the second largest, it is 5,83,000. And Meghna is 65,000 square kilometers as per the study done by Kondu and some others, Kamal and all. Weather and hydrologic data, daily precipitation, maximum, minimum temperature data, it is on certain period 2001 to 2012 are collected for the Princeton Global Forcing version 2 model for the meteorological and other purposes. And model setup, it is very much important, and calibration validation also important. Stream networks are delineated in SWOT with a minimum drainage area threshold 1,500 square kilometer using the dam of the basins. Later, the outline of the complete basins are delineated by considering the basin outlets at Hardin's Bahadurabad Transit, and Bhairav Bazar GBM basins, respectively. For the calibration and validation, we just make it 12 years divided into two equally segments, one for calibration, that is 2001 to 2006, and for the validation, 2007 to 2012. And model are performed at a daily time step. So one important thing is for the calibration and validation is the selected parameters used calibrated models in this study. And the important thing is that various value that is called tested p-value, NSC, and various bias, and the values are selected with the sensitivity of the regions as well. And for the future climate projections, SST and CI's concentration boundary condition used in this atmosphere GCM global circulation model collected, and the list is showed here. And for the significant specific warming level, especially 4 degrees Celsius, some are the beyond the scope, which are marked in the bold, 2113 or 2096. These are ignored for this study. So future climate projections, as for the study and the analysis, it is show that the special distribution of the changes in the ensemble means of the mean annual precipitation and mean annual temperature data used in the study at different specific warming level compared with the baseline period shown in the figure. So in the left panel, it is showing the changes of 1.5 degrees Celsius, changes at second is that changes at 2 degrees Celsius, and the bottom ones show the changes at 4 degrees Celsius. And for the mean annual precipitations, in the right panel, it shows the mean annual temperature at different changes at different what is called at 1.5 degree, 2 degree, and as well as the 4 degree. So for the calibration and validation, we just differentiate the things in two different way. One is for the 2001 to 2006, another is for the 2007 to 2012. So it is the value for the different three basins that is shown in the table. Ganges for the calibration and validation of NSC is 0.8 and 0.77. It is quite a very significant value. For the R square, it indicates 0.8 or 0.79, and P bias is 12 to 15. And some other factors also showing some significant. And for the Brahmaputra, it is showing 0.81 for the calibration value and validation 0.79, and R square is 0.8 or above, and also for the Magna Basin region. So the thing is that the special distribution of changes in the ensemble means of the mean annual precipitation. Just a minute. Okay. So the after this is compared with the observation as well as with the simulation. So after the calibration, the validation also showing the some significant findings of the study. Then we compare the climate sensitivity of
Dr. Mohan, I think you
Yes,
can
sir.
you can move to your main part.
Yes, sir.
Quickly, because
Okay.
organizer has already told me that we are running out of time.
Okay, sir. It is the findings. So maybe 1 or 2 slides. I can finish, I think, within 2-3 minutes. It's all right, sir?
Yeah, it's okay.
Okay. Thank you, sir.
Yeah.
Okay. So the important sensitivity, and we compared the GBM basins, the changes in the annual discharge simulated by the SWOT for the 2006 to 2099 is showing the figure. Top panel left is for the precipitation change for the Ganges, and second is for the Brahmaputra, and third is for the Meghna. And also the percentile, 19 percentile shows in the right panel. So if we explain the figure for the left one, that is the precipitation change with the discharge change, we can indicate that the anomalies, both discharge and the precipitation in a particular year are compared with baseline periods. As I mentioned, 1986 to 2005 is considered for that, and all 13 climate projections. So in the Ganges basins, all the values are coincide, but Brahmaputra and Meghna is showing a bit differently. And that is the one important findings, changes of flow in the river and floods. So if we see the top panel, extreme 5-day precipitation at the Q99 or 99 percentile. So under the scenario of 4 degrees Celsius, it is very much extreme. And also for the, if we consider the precipitation greater than 100 millimeter, so it also showing the in the 1.5, it is a bit good, but in the scenario of what is called 4 degree, it is very much extreme in the, especially in the Sylhet and Teknaf and central part of Bangladesh. So in this study, we see the discharge, combined discharge data with the number of days with which peak coincide with the baseline and three different scenarios. We found that how it changes. The fraction of discharge contributed in the Magna River to combine with the GBM flow at any given year is relatively small. Also, if we check the synchronization, it is found that the study considered the combined of Ganges. This is the what is called below panel, showing the Brahmaputra and GBM separately showing in here. So if we consider the findings of the study, it is showing that 1.5 degree, 2 degree, and 4 degree Celsius scenarios, the future projection of daily flows of the GBM rivers that are simulated with SWOT hydrological model. So the model showing with the ensemble of 13 climate projection generated with two high resolution GBM model which are used here. So the changes, future river and floods are analyzed, and 90 percentile flow and 100-year return period flows are showing, and flood magnitude in Bangladesh are projected increase in the future compared with the present. Also, here projected increases, duration of future floods also projected how it is increases. And if we consider the total results, it indicate that low-lying delta regions like Bangladesh, synchronization of peak discharge can be critical factor from flood assessment at any standpoint. So in it is need to be considered that Brahmaputra Ganges peak synchronization positively is projected at 4 degrees Celsius, while the largest increase is GBM peak synchronization positively is projected 2 degrees Celsius as per our study. So thank you for your kind patience, and I'm sorry for that time limitations. Thank you, sir.
Thank you, Dr. Dash. I think this is a very good work. And I also know that you have a number of publications on this work. Particularly one paper I remember, it has been published in ASC Journal of Hydrologic Engineering. And I saw that many of the materials are from that paper also. Anyway, thank you so much. If anyone has any question, you can either put it in chat box or you can directly ask to Dr. Dash. It seems everybody is tired because the session started in the morning at 11.
Sir, I have a question.
Yeah, sure.
Yes. This is Dr. Lutfur Rahman. My question is, how many percentage of flood increases on the baseline reference year, considering the reference year in his prediction? That's,
thank you. In this study, it is showed that that like three different warming level as we consider 1.5 and 2 degree and 4 degree. So the percentage is for three different what is called Magna, Brahmaputra and Ganges. For one is 27%, another is 29%, and is 54% respectively. That is for the what is called for in the I just explained for the Ganges it is 27%, 29%, and 54%. And simultaneously for the Brahmaputra, it is a bit less. For 1.5, it is 8%, and 2 degree it is 24%, but 4 degree it is 64%. And finally, for Magna, 1.5 it is 15%, and 2 degree is 38%, and but for 4 degree in the Magna it is 81%.
What is your baseline data? 90 is the baseline.
Yes, to the up to the 2006, 1985 to 2006.
85 to
2006. Yes. This is the baseline.
Thank you. Actually, actually the prediction covered the year that we have considered, and as you have mentioned, the increment of flood is already really happened. You know.
Yes, sir. Sorry.
have you any check it? Have you checked the increment that you have mentioned in the river? Your prediction is
changing with the, I mean, increment checking with the baseline.
yeah,
The
yeah,
baseline
Yeah,
is
it is.
following the same trend.
Yes,
follow
sir,
the
it is.
trend in the real river.
Yes, maybe I might maybe not understand the question clearly, but for 1998 floods and 2008 floods, we have checked how the model simulation is performed. So accordingly, we just for the two floods we actually checked.
Oh.
Okay, thank you, Dr. Mohan, for the responses. And I mean, you can also communicate later through emails
Yes, sir.
or
Thank
over
you, sir.
phones to
Thank you.
further clarify. So we move on to the next presentation. Next presentation is on challenges of projecting rainfall for Dhaka city. It will be presented by Mr. Mohammad Sadman Saqib. I heard earlier from the organizer that he's not present here. He's there. Okay. So please, Sadman, you can continue.
Okay, thank you, sir. I'll be presenting our paper just to start off.
So Mr. Sadman is a lecturer at the Institute of Water and Flood Management.
Thank you, sir, for the introduction. Can you hear me?
Yeah, we can hear you well.
Okay, I'll be presenting our findings and also our study on challenges of projecting rainfall data for Dhaka city. Firstly, I will be talking about the Cordex RCM model dataset that we have used to project rainfall, to analyze the projected rainfall by Cordex. And then we'll be moving on to the analysis of Cordex dataset in terms of seasonal variability and total annual rainfall, so that we can get the best model without doing the bias correction. And also we'll be looking into the ensemble model characteristics for different climate indices. Following that, after that, we'll be moving on to applying bias corrections, specifically quantile mapping, and also we'll be looking to the results of the bias correction. Okay, so the under CME 5, the Cordex model have a total of 17 models. The Cordex model dataset has a total of 17 models. We actually downloaded all the dataset from Cordex website. And we actually downloaded the whole dataset for the whole Bangladesh. Here you can see the precipitation variability of the 17 datasets throughout Bangladesh. So there is significant variability where some of the datasets shows very high amount of rainfall, whereas some of the other datasets show very low amount of rainfall. So the variability all over Bangladesh for the 17 models is really high, especially if we look into the hilly region. The variability can be hilly region in the Sylhet and also in the Chattogram area. The variability can be seen to be very high from model to model. But for our study, we actually focused on the specific data set on Dhaka. So our Dhaka area is closed in the very middle of the Bangladesh. So in our next slide, I'll be looking into only the portion of our Dhaka city. So our Dhaka city, for the Dhaka greater area of Dhaka district, we can see the variability of the 17 models right here, around here. Here we also can see significant variance in the total amount of rainfall that has been projected over the year. And here we are seeing that's just the average of all the models. So following that, I've just shown the trend of the average model against our reference data set, our BMD station from Dhaka Agargaon. So as you can see, the BMD station is in black line, and the other 17 models that we have has a huge kind of variability. For example, in some models, the maximum precipitation in the month of May to August is almost double of the actual reference or actual observed data of Dhaka. on the right side of the slide, you can see that ensemble plot for all the 17 models that we have for the reference period of 1976 to 2004, and following on to that, the projected section from 2005 to 1995. Here here easily it's understandable that the total rainfall that has been projected onward from different model has a good amount of variability, approximately within plus minus range of 150 1500 millimeter of rainfall each year. And as you can see, also the RCP5 and RCP 4.5 scenario and RCP 8.5 scenario both has very erratic behavior and does not show any clear pathway like the temperature data usually shows. And so the precipitation data and the projected data variability is significantly high from model to model. So from the 17 models, we actually used, I have to mention that these 17 models are not bias corrected. And from the 17 models, we actually short it down. We have selected only 8 models based on 2 sets of parameters. Firstly, we looked into the seasonal variability. In number 1, we can see that the precision model, which actually follows the trend of our rainfall data, like we have very high rainfall in the monsoon season in the month of May, June, July, August, September, are selected first. The first best of the 8 model based on the deviation and the from the data sets had been selected in the first step. Following that, we actually looked into the total amount of rainfall that each of the data set produced for each significant year. That's our second criteria of selecting the model. So the model was firstly selected on the seasonal variability, and finally it was selected on the annual variability. So this so our final selection can be seen here as the 4 models. So in the next slide, I'll be elaborating on the characteristics of the 4 models. So here you can see the 4 models which have significant variability from the reference data set. But some of the models, like the best performing one, like CCCMA, RITM, has actually the similar trend to our observed data set. However, in the months leading to the monsoon season, January, February, March, and April, it does not actually follow the actual observed trend. Whereas the MIRCO, micro data set, which actually follows the total curve of our observed BMD data, it does not have a significant match with the values of rainfall. Rather, it overpredicts is over by 150 millimeter. So just to understand how variability works from a reference data set, from the on the right side of the graph, you can see that we have plotted the maximum error bars for the RCP 4.5 and 8.5. The ash colored graph, the graph which can be shown, shows the total error, average error for the 17 data sets, whereas for the blue colored one only shows for the selected 4 models. We can easily show that the average error actually reduces as we select the 4 models rather than the 17 models. Similar things happens in the RCP 8.5. However, the error in RCP 8.5 reduces significantly compared to the average model of compared to the average of the 17 models. So I'll be just showing the characteristics of projections for the 4 selected models we have just selected based on the annual and the seasonal variability. So as you can see, the consecutive dry days for RCP 8.5 and RCP 4.5 actually shows to slightly increase. However, the p-value in this study was very insignificant, and it shows that the variability in the future year does not show a consistent trend either for RCP 4.5 and 8.5. So for the next indices, climate indices, I will be talking about the consecutive wet days. So here you can see a slight decrease of consecutive wet days as we go forward to the 2050 onward. However, there is no consistent trend for how the rainfall will be changing based on the RCP scenarios. This is one of the more interesting things, like the R20 mm parameter, where the rainfall is higher than 220 millimeter per day. Here you can see the variability also has a significantly high margin, and also there is no significant trend between the RCP 4.5 and RCP 8.5 models. So based on this data sets, which is not bias corrected, we can see that the rainfall's precipitation data for Cordex has significant variability. So following that, we actually applied bias correction. We use quantile mapping so that the bias correction does not actually modify the actual underlying trend of the original data set, and also it's able to capture the actual extreme events. In the right side of our screen, you can see the Taylor diagram for the unbiased corrected 17 models we have in the system. Here you can see that correlation between the observed data set and the models, although 17 models is really, really low, is close to 0.1 to 0.2. However, the standard deviation is also not really good. And we can see some of the models having very high standard deviation from the observed data set of BMD. So here we have used 5 techniques: the PTF, the parametric transformation, the quant technique, the robust empirical quantile technique, RQuant, the smooth spline technique, SSPLN, and also the distribution transfer function for distributed model, DIST. So in the next slide, I'll be showing our best 2 models that were selected based on the our seasonal annual variability. Here you can see the CCM MA and the MICLO. After applying the bias correction, shows a significant shows changes, but however the trend is not very consistent with the reference the data set. Following that, we can also see that the Taylor diagram for different methods, for example, the quant section actually causes the bias corrected data set to have a really low amount of standard deviation from the reference data set. And here we can see the all the model being clustered. However, the correlation remains really low and close to 0.1. And in the other techniques like SSPLIN, we can see that the correlation is between 0.1 to 0.2. However, the standard deviation is increased. Finally, we found our best model, best method for bias correction to be RQuant. Here we can see still the correlation between the observed data set and the Cordex models does not show significant correlation. Rather, the correlation remains 0.1. However, the bias corrected set of data has a very low amount of data, very low amount of standard deviation. So from our study, we found that the RQuant found the best for the precipitation data, and however the standard deviation is really low. Apart from that, none of the bias corrected quantile mapping system couldn't actually capture the actual trend and bias corrected data, so that we have high correlations with the rainfall observed rainfall data. So that's from my presentation. I sorry for my presentation being some lacking about my speaking.
Thank you.
Yes, sorry, sir.
Yes. If anyone have any quick questions, we can take 1 or 2 quick questions.
Can I ask a question, sir?
Yeah, sure.
Thank you, sir. Actually, Sadma Sakib is a very nice presentation. Here he used the Codex 17 model, and I think that he tried to the best 4 model. And here one thing that consecutive word frequency, I observed that little bit decreasing word frequency. Have you after bias correction this or not after before bias correction or after bias correction this?
Oh, sorry. The consecutive weight trace, dry days, and the consecutive weight days, all these are non-bias corrected. Yeah. These are the raw 17 model data for the best 4 citizen models without doing any kind of bias correction. Yes, sir.
Thank you.
Okay, thank you.
Thank you, sir.
Any other quick question? Thank you, Sadman. I find that you are pointing to the extent that there are uncertainties associated with the use of climate model projection. That is very important, and also it indicates that we need to tailor to the location where we want to use it. So in general, one particular model may not be good for every location. This is also mentioned by other speakers that some model can capture peak very well, some model can capture annual. So these sort of uncertainties should also be considered while we pick the model. Thank you for your nice presentation.
Thank you, sir.
So we move to the last presentation of this session. This is also on Indian summer monsoon rainfall using Cordex South Asia data. So this will be presented by Dr. Sharma. Dr. Sharma, you are here?
Good evening, everyone. Good evening to the session chair and session co-chair. I'm Akanksha Sharma. I would like to share my screen. Thank you. Is my screen visible?
Yeah, I can see it, but you can make, you can, make it bigger.
So today I'm presenting on assessing Codex South Asia in representing Indian summer monsoon rainfall. I am from India, from Jawaharlal Nehru University, and I am doing my PhD under Professor A.P. Dimri. So everyone knows Indian summer monsoon is responsible for highest precipitation, that is 80% of the total annual precipitation during the month of June, July, and September. During this period, the precipitation has a large degree of spatial and temporal variability, which global circulation models, that is GCMs, are unable to capture. So RCMs, that is regional circulation models, are used and are suitable to capture the process related to this phenomena and the regional processes. However, RCMs also have bias towards the actual observations that prevent them from accurately simulating the climate. In this study, I am using World Climate Research Program initiated coordinated regional climate downscaling experiment South Asia, that is Codex SA, to carry out or to assess Indian summer monsoon and to compare which model experiment of this suit better represent the summer monsoon precipitation. The Codex SA consists of 17 GCM RCM combination and 2 reanalysis data at a horizontal resolution of 50 kilometers. The flow of my presentation is as such: study area, precipitation climatology, precipitation bias, correlation coefficient, probability distribution, interseasonal oscillation, and then at last conclusion. My study is based on the Indian subcontinent, and the box shown in this figure is considered as a monsoon core zone, which represent the summer monsoon precipitation over India. For my study, I considered 19 RCM GCM combination in which GCMs are downscaled using 3 RCMs, that is RegCM4, RCA4, and REMO. In my study, I am comparing all these models on the basis of spatial resolution, temporal resolution, intraseasonal oscillation, to assess which model represents summer monsoon better and which models we can use for our further studies. First of all, climatology, that is JGS mean precipitation of Codex SA model experiment with corresponding Indian Meteorological Department observation is presented. In this, all the models are validated against IMD observation. From this, we can see REMO model experiment, that is highlighted on the model in the red box, represented or resembles more to the IMD observation, whereas the RCA models shows or RCA models shows less precipitation or precipitation with the less magnitude underestimate the precipitation over northeast India, whereas overestimate the precipitation over central India. Whereas few models such as CAN-ESM, CSIRO, HEAD-GEM, IPSL, MIROG overestimate or underestimate precipitation over northwestern part of India, which is also reported by Samuelson et al. 2011. If we talk about the RegCM model experiments, all the model experiments underestimate precipitation over precipitating maxima zone, that is Western Ghat, here it is, Northeast India and Central India, whereas it overestimates precipitation over North India. A similar kind of study or similar kind of pattern is observed from the bias of model experiment. In this, we can see all the model experiments of RegCM shows wet bias over North India, whereas dry bias is seen over the maximum precipitating area, that is Northeast, Western Ghats, Central India. In Remo model experiment, all the area have a moderate bias, whereas RCA shows wet bias over Central India and dry bias over Northeast India. Grid-wise or grid-specific correlation coefficient is calculated for all the models over monsoon core zone and India. This correlation shows MPI Remo shows the highest correlation coefficient when calculated over India, that is 0.7, and CAN-ESM RegCM shows the highest correlation over monsoon core zone, that is 0.5. To assess the data distribution, probability distribution is plotted. In this, we can see the black line represent the curve for IMD observation. Here we can see the peak intensity or magnitude is at 7 to 8 mm per day. Most of the experiments of Codex SA are representing this distribution well, but are little bit skewed. If we talk about the best model representing or resembling the IMD observation is the MPI Remo, which is closer to the IMD observation. Models are also evaluated on the basis of intra-seasonal oscillation. For this, ensemble of all the Codex models, that is for 19 models, ensemble is calculated, and active and break spells, lag composite of active and break spells is plotted. For calculating the active and break spells, basic standardized anomaly value is averaged over monsoon core zone for July and August time period, with standard deviation greater than or equal to 1 for 3 consecutive days is defined as the break days, whereas standard deviation less than -1 for 3 consecutive days is represented as break days. If we look at this, for the active period, all the for active days, lag precipitation is calculated the interval of 2 months, and all the intervals are representing, northward propagation is represented well by the Codex SA, but lag 0, specifically lag 0, is better represented by the Codex SA ensemble. If we talk about the break phase, models shows high precipitation over north-west part and over central India as well. For the break phase, they are resembling the IMD observation, but with some high magnitude in the precipitation. If it at last the conclusion, all the models of Codex SA represent the spatial distribution well, but MPI Remo resembles more to the observation and has the least bias and high grid specific correlation over India. And intra-seasonal oscillation is also well captured by the Codex SA ensemble. Specifically, active days are well represented by the ensemble of Codex SA, then break phase. Thank you.
Thank you, Dr. Sharma. You finished or you said you are doing your PhD?
No, sir, I am doing my PhD.
Okay, then I should say Miss Sharma. Thank you for your nice presentation. And also, I think this is very important in terms of understanding the reliability of the model. I mean, even this sort of information, sometimes we are
Yes,
overflown with the available information. So this is very interesting. But I mean, I have one question. When you said that you calculated grid scale correlation, what do you actually mean by that? I mean, whether it is
How?
based on average or, I mean, is there, I mean,
It is
what is the particular
Yes, sir.
way?
It is grid specific. How each model is at each grid correlation is calculated and then it is averaged out. How well each model is representing the rainfall in comparison with IMD observation at each grid. Because if earlier you mentioned that at every area, some models behave well over, let's say, in east, and some model behave well in the west. So for each grid, correlation coefficient is calculated and then it is averaged out.
Yeah, I mean, this is a very nice way of doing, but I have heard from some modelers that calculating correlation is not really meaningful because the model itself has some statistical element, not really dynamic element. All the elements are dynamic.
Yes, sir. Models have their biases and uncertainties, but we have to see which models capture the processes or variables better so that we can predict our future, as it helps in predicting the future. So it is somehow it is important to capture the correlation, how well it is measuring all the things and all the variables.
Okay, we can take one or two quick questions if there is a specific question. We still have about 8 minutes of time. Thank you. Very interesting work. So there are some.
Yeah, I have a question to her.
Yeah, sure.
Sorry, time is very short, lacking, but I have a question. And so you showed us the pattern of lag correlation about the interest and variability in the very last slide. So,
Yes, sir.
So you told that it is somewhat better, but I think that the spatial pattern of the lagged correlation seems somewhat very unrealistic sometimes. What do you think about that?
So spatial correlation is shown for each model experiment, whereas intra-seasonal oscillation is calculated for the ensemble of all the codex members. So that is why it is differentiating.
Maybe so that I think that the codex model can also not be able to reproduce the interest variability in many models.
Yes, sir. We still need some models which have more fine scale. Or recently, codex score, that is phase 2 of codex. The codex score is there, or project is initiated by WCRP, and I'm also doing some research kind of which model is better for codex score, as it has a resolution of 25 kilometers, whereas codex SA has a resolution of 50 kilometers. So still, when I look about into the papers of codex score, still there is a lot of improvement is required if we talk about modeling, as they have their biases, uncertainties, and not representing the actual observation, and not even similar. Some models, like if you talk about, when I was calculating the correlation, some models are showing correlation in negative as well. So still a lot of improvement is required in their downscaling or parameterization.
Yeah, thank you very much. So very interesting results. Yeah.
Thank you.
Terasan, we have finished all the presentations, so you can now take over to conclude.
Yeah. Okay, thank you very much. And we have 6 minutes only. So, but if you have any question for some specific or some overall, then we can have some comments or questions from your side. So you have any?
I have one question to Dr. Mohan actually. In his presentation, he talked about peak synchronization. When you talk about peak synchronization, it was not very clear from his presentation whether he's talking about peak synchronization or combined flow, because he used combined discharge. That means the summation of all the discharges. To me, it is not really peak synchronization. If he can clarify this, that will be useful.
Okay, sir. Thank you. Actually, it is a co-work with me and my team. So it is actually peak synchronization. So maybe that part is not very much related to me. So I think I need to discuss.
Okay.
Thank you, sir. You're rightly pointing.
Okay, thank you very much. So, any question or comments? Okay. Maybe we have almost 4 minutes. So now maybe we come to the time for the concluding this session to A. And so from me and so Mondar-san, please have some comments later. So I have some comments about this session, and so that these results all overall showed that many newcomers for the climate change research is coming, and so this interaction is very important. So thank you for coming to this session. That's the first point. And second one is that we again faced how that the climate projection or climate reproduction is very difficult. How is it difficult? So I think this portion has to be much more investigated. So how this model has error like this. So it's very important information. So before doing some bias correction or other things, we have to look much more into the error mechanisms. This is my comment. Yeah, thank you. And so Mondar-san, please.
Thank you, Terao-san. Actually, we have seen 6 presentations. These presentations are on mainly precipitation, but there was one presentation on heat wave, and also in one presentation there was temperature change. One presentation from Dr. Mohan was on future flood. In terms of country, I find that one presentation was from India, and the remaining 5 presentations were from Bangladesh. All the presenters did actually very well, and most of them have PhD degrees, so they are mid-level to senior level presenters. So I find that the quality of the papers are very good. Of course, there are some areas of improvement. So I would encourage and suggest to the authors to improve those areas and also publish the papers in reputed international journals. With this expectation, and also hope that you will carry on your ongoing work. I thank the Department of Meteorology, University of Dhaka, for inviting me and also you to chair and co-chair this session. Particularly special thanks to Dr. Tauhida and her team. I have been fortunate to co-chair all the 3 international conferences that they have hosted so far. So thank you so much for giving me the opportunity to co-chair this session. And it has been very nice to work with you. Hope we'll continue our working together. Thank you.
Thank you, Mondar-san. So it is a totally very nice sum up of this session, and also very thankful for me for all that participants. Also, Tauhida-san, thank you very much for giving me chance for chairing this very nice session. So now we have to finish this session, and we may have much more big collaboration for the change research. Yes, thank you very much. So please. Now come back to that office piece.
Well, thank you, Professor Terao, and also Professor Mondal sir for nicely moderating the session. And it's very, I mean, it's a really good thing to note that you've actually finished before the schedule. You still have 1 more minute if you want to talk. So again, I'd just like to extend my gratitude to both Professor Terao and also Professor Mondal for nicely moderating the session, and also all the presenters who have been presenting their talks and nicely presenting their research as well. So this concludes our second session. We'll have a break for 10 minutes and then we'll come back for the next session. Again, that session is also impacts on impacts and challenges of climate change. So see you in probably 5 or 6 minutes. Thank you. Thank you so much.
Shurab, may you request for everyone to a group photo? I think that will be a good memory.
Okay, so in that case, I'll ask all the presenters. Yes, please just take a quick snap.
Yes, sir. Sorry, wait a minute.
Oh, sure, sir. Obviously.
Okay, okay. Now we can take it for.
Okay, sir.